This video is just to serve as an example of how to use unit or dimensional analysis to solve some problems where there's a conversion involved. So this is a skill that will be very helpful definitely in chemistry, but also in physics and in some biology applications. It's a technique we use many times, for instance, in the healthcare field where we're calculating drug dosages and things like that. So let's look at this example here. It's from the textbook. It says, what is the decigram mass of a wheel of a cheese that weighs 0.515 kilograms? So we're just going to convert from kilograms to decigrams. So this is just a metric conversion. The amount of units in each of those is up to you to memorize, how many decigrams are in a kilogram and so on. But just to show you how this would work, we're going to take what we call the singleton. And I call it a singleton because the units only have one term with them. Later on, we'll see things like grams per centimeter cubed. Anything with that type of unit wouldn't be a singleton because the unit has two components to it. But for right now, we're going to start with our singleton because the 2-unit ones are generally going to be conversion factors that we'll use throughout this calculation. So here we go. We start with 0.515 kilograms. When we use dimensional analysis, the way we get rid of the units we don't want is to cross them out by multiplication of a fraction. So that means that I'm going to put kilograms in the bottom of my conversion. How many kilograms are in a gram and so on? So 1 kilogram equals 1,000 grams. So now my kilograms are going to cross out and I'm in grams. That is not, however, where I want to be. I want to try to get to decigrams. So I do another conversion factor, and I say, well, I know that 1 gram is 10 decigrams. So now my grams will cancel out, and I'm in fact left with what I was looking for, decigrams. And if you just put that into your calculator, so multiplying across the top and then divided by the things on the bottom, you would end up with 5,150 decigrams. So this is how we use dimensional analysis. That unit analysis or dimensional analysis is this crossing out of units by putting them in the top or the bottom of a fraction. So the hints here are to start with the singleton and then make sure that you can cross out your units as you go down and then only get left with the thing that you're looking for.